Hello, today we are going to go through our data analysis study guide. So the first part here says to match the vocab terms with their definitions. So the first word here that I see is mean. So remember, the mean is just taking the average of the set of numbers. So I see the average of the set of data right here. So I'm just going to draw a line connecting those two. Next word is median. Median is talking about the middle set, the middle number of the set of data. So that is this one right here. Mode means most, so the number that occurs the most. So that is that definition right here. Range, that is taking your biggest number minus your smallest number. So that is talking about the spread of the data. And then the last one, interquartile range, that's taking the range of the quartile. So that's taking the spread of the data of your quartile. So that is that one. And if you want to put arrows, you can. But those are your definitions. Okay, now the number two, when you're talking about measures of center, think about which definitions up here talks about the center of the data. So the only two that talk about the center of the data is the mean and the median. Those are the only two vocab terms that we talk about that talk about the center of the data. So your measures of center are mean and median. Okay. Then measures of spread, well, we have the spread of the data right here that talked about the range. And then you also have your interquartile range. So your measures of spread are the two ranges. So you have the range and you have the interquartile range. So mode is neither of them. Mode is just there. Okay, so your measures of center are the mean and the median, and your measures of spread are the range and the interquartile range. Okay. All right, moving on to number 4 and 5. So based off of visual inspection, which animals appear to have a larger range of weights? So remember, range is talking about the spread of data. So if we're looking for the larger range, we're looking for the more spread out data. So here we have the house cats and here we have small dogs. So which one appears to have a more spread out data? Well, if I'm looking, this one definitely looks bigger and has a more range than the house cats. So the ones that appear to have a larger range is going to be the small dogs. So the more spread out data. Okay. Number 5, based off of visual inspection, which animals appear to have more predictability? So if you want to predict something, you want the smaller range. So predictability, we want the smaller spread. So in other words, the smaller range. So if small dogs have the bigger range, that means that the house cats is going to have the smaller spread. So the house cats are going to be more predictable. So larger range, you're looking for the more spread out data. Predicting something, predictability, you're looking for data that's not as spread out, so more closer together. All right, number 6, if 18 out of 21 people like the Colts, predict how many out of 500 like the Colts. So guys, as soon as you guys see 3 numbers within a problem and you're trying to find a missing number, set up a proportion. Okay, so I see 18 out of 21 people like the Colts, so that's my first fraction here. 18 out of 21 people like the Colts. And we are going to predict how many out of 500 like the Colts. So that's going to be my second fraction in my proportion. So 500 is talking about the total, so the total goes on bottom. And we're trying to figure out how many people out of 500 like the Colts. So once you have your proportion set up, just solve it. So cross multiply, 21 times x is 21x. 18 times 500, got my calculator here, it's 9,000. To get x by itself, just divide by 21 on both sides, and we get x equals 528.5, but since we're talking about people, you can't have partial people, so you're going to have to round this to the nearest whole number. So if this is 0.5, it is 5 or greater, so I'm going to round my 8 up to a 9. So this would be 429 people out of 500 would also like the Colts. Okay, and then the last one, name the outlier in the data set. So remember, an outlier is a number that is much smaller or much larger compared to the rest of the numbers. So I have a 90, 91, 91, 87, 51, 83, 100, 95, 86. So the number that I noticed that is a lot smaller than the rest is 51. So that would be your outlier. Okay. All right, moving on to the second page. All right, so second page, use the graph below about the heights of players on a team to answer questions 8 through 13. So if you guys notice 8 through 13, they're just wanting us to name the parts of the box and whisker plot. So if you guys remember, on a box and whisker plot, you have your lower extreme and your upper extreme. And remember, the lower extreme and the upper extreme is just your minimum and your maximum number. The box, so the outsides of the box, is what makes up the quartiles. So your smaller number is your lower quartile, and your bigger number of the box is your upper quartile. And then your point that's in the middle that makes up, like splitting up the box into two different boxes, that's your median. Okay? So look at number 8. Name the upper extreme. So again, your upper extreme is just your maximum number. So it looks like our maximum number here is 84. Number 9, name the lower extreme. So that's your minimum. So that's your smallest number on the box and whisker plot, and that is at 72. The lower quartile, that's your smaller number that makes up the box. So the lower quartile is at 75. The upper quartile, that is the upper part of the box, so that's 82. Median is your middle number, so that is 79. That's the point that's in the middle. And then name the interquartile range. So remember, to find the interquartile range, just think of what range means. Range means you're taking your biggest number minus your smallest number. And then quartile is in the word interquartile. So all that you're doing is you're finding the range of the quartiles. So you're pretty much just taking your upper quartile minus your lower quartile. So we said the upper quartile was 82. We said the lower quartile was 75. So 82 minus 75 gives us a interquartile range of 7. All right, moving on to the next one. So now we have a dot plot, and they want us to find the minimum, the maximum, and the mean. So remember, these dots, we can write all of these numbers out if we really wanted to, and they would just create a long list of numbers. So like we have 3 dots at 21, which means we have 3 number 21s. We have 2 dots at 23, so we have 2 23s. We have 4 dots at 24 and 4 dots at 25. And I ran out of room, so I'm going to go down here. We have 126 and we have 3 27s. So instead of writing out all of these numbers, it looks a lot nicer whenever you create a dot plot. So that's why we have dot plots, is to make numbers look nicer, especially when you have a lot of the same numbers. Okay? So name the maximum number. What's the biggest number that we have here? Well, the biggest number that we have is 27, so that's your maximum. Your minimum, now please don't get confused that you guys see 20 on here, because a lot of students, I remember from a couple years ago, they were like, oh, 20 is on the number line and that's the smallest number that I see, so my minimum is 20. However, are there any dots at 20? No, so you can't say that 20 is the minimum because there's no dots. So your minimum is actually going to be 21. And then the last thing that you guys have to do is find the mean. So remember, to find the mean, you're just finding the average of the numbers. So all that you're doing is you're adding up all these numbers and then dividing it by how many you have. So I'm going to take 21 plus 21 plus 21 plus 23 plus 23 plus 4 24s plus 4 25s plus a 26 and plus 3 27s. Hit equals, and that equals 412. And then we need to still divide it by how many numbers that there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm going to take this number divided by 17. And it does tell me to round to the nearest tenths. So if I'm rounding to the nearest tenths, I need two numbers after the decimal point. So we have 24.23. If I'm rounding to the nearest tenths, I'm looking at this number and I'm looking at the number behind it. If the number behind it is 5 or greater, then I'm going to round the 2 up to a 3. If it's not 5 or greater, I'm just going to leave the 2 alone. So in this case, since 3 is not greater than 5, I'm just going to mark it out, and rounding to the nearest tenths, my mean is going to be 24.2. And again, your mean is the average, so it should be a number that will fall within the center of the data. So as you guys can see, the center of the data does lie around this 24, so I should have known right away that my mean is going to be somewhere around 24. All right. Next one, a survey found that 8 out of 20 students' favorite sport is soccer. If there are 550 students in the school, predict how many of these students would prefer soccer as their favorite sports. So again, guys, as soon as you see 3 numbers in a problem, you want to set up a proportion, okay? Your first proportion is going to come from that survey. So it says 8 out of 20 students like soccer from the survey. Then we're trying to figure out how many students out of 550 would also prefer soccer as their favorite sport. So your total always goes on bottom, and we're trying to predict how many students out of 550 would also like soccer. So once you have your proportions set up, go ahead and cross multiply. So 20 times x is 20x. 8 times 550 is 4,400, and then we can divide both sides by 20. And we get 220 students exactly. Alrighty, moving on to number 18. So a survey found that 2 out of 10 students do not have a sibling. What is a reasonable prediction for the number of students who do have a sibling? So they try to trick us here, giving us the number of people who don't have a sibling. Well, we're trying to figure out how many students out of 500 do have a sibling. So there's a couple different ways to do this. One way is to use the numbers, so like 2 over 10 equals x over 500, and figure out how many don't have a sibling. And then your last step, you would have to take one extra step, and you would have to subtract 500 from your answer to figure out how many do have a sibling. Or just take the number from the survey. So if they say that 2 out of 10 students don't have a sibling, that means how many students out of 10 do have a sibling? If you guys said 8, that's correct. Just take the 10 minus 2, and that gives you 8 out of 10 students do have a sibling. Okay, so now we're just trying to figure out, okay, if 8 out of 10 students have a sibling, then how many out of 500 would also have a sibling? So again, I saw 3 numbers, so I'm setting up a proportion, and I'm going to solve it. So 10 times x is 10x. 8 times 500 is 4,000. And then to get x by itself, divide by 10 on both sides, and we get x equals 400 students. All right, moving on to number 19. Which gym has a greater range of attendance? So range, you're just taking your biggest number minus your smallest number. So in a box and whisker plot, we're pretty much just taking our upper extreme minus our lower extreme. And really, we don't need to do the calculations here because we can just look at the graphs and see which one has a greater range. So looking at the two gyms, we have Fun Fit Gym and we have Greg's Gym. Which one is longer? Fun Fit Gym, right? Your lower extreme and your upper extreme were going from 140 to 80. Greg's gym was only going from 140 to 90. So the gym that had the greater range is Fun Fit Gym. All right, moving on to questions 20 through 24. So we need to find the mean, median, mode, and range, and an outlier within this set of data. So remember, guys, whenever you're finding the 3 M's and the range, you must put your numbers in order from least to greatest first, okay? So my smallest number is a 3. Then it goes to 18, 19, 20, 26, and 35. Oh, I forgot 32. 32 and 35. So I have 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7 numbers. Yep, so I got them all. Okay, so let's find the mean first. So remember, guys, to find the mean, you're just adding up all the numbers and dividing it by how many you have. So we're going to take 3 plus 18 plus 19 plus 20 plus 26 plus 32 plus 35, and that gives us 153. And then we are going to divide it by 7 because we have 7 numbers. And it says to round to the nearest tenths. So here we have 21.85. So again, if I want to round to the nearest tenths, I'm looking at the 8 and I'm looking at the number behind it. If it's 5 or greater, I'm going to round the 8 up to a 9, which in this case I am. So the mean here is going to be 21.9. Median is your middle number, so we had to put the numbers in order from least to greatest to find the median. So I just use my fingers and I work my way in until my fingers meet. And in this case, they're going to meet at 20, which will be the median. Mode is the number that occurs the most, and there's no number that repeats, so I'm just going to put that there were none. Range, that's taking your biggest number minus your smallest number. So here we're going to take 35 minus 3, and that will give us 32. And then your outlier is a number that's a lot bigger than the rest of the set of numbers or a lot smaller. So the only outlier that I really see here is the number 3 because it's a lot smaller compared to the rest of the numbers. Okay. Answer questions 25 through 26 about the table below. So 25 says that there's 53 12th grade female students who were surveyed in all, and as you guys can see, if I were to actually add these up, 46 plus 7 does give me that 53 that they're talking about. Okay, so there's 53 female students that were surveyed. If there are 200 females in the 12th grade, predict how many are left-handed. So I need to look at this table up here to figure out how many out of the 53 12th grade female students that were surveyed said that they were left-handed. And as you guys can see, it says that there were 7 females who said that they were left-handed out of 53. So that is my first number in my proportion. And guys, if you haven't figured it out by now, anytime that it says to predict something, you're just setting up a proportion like we have been doing. Okay, so you need to find 3 numbers and set it up to find your missing number. So 7 out of the 53 female students said that they were left-handed. So now I'm trying to figure out, okay, if there's 200 in the 12th grade, how many of those would be left-handed? So my second fraction is x out of 200. And then now I can just solve it. So 53 times x is 53x. 7 times 200 gives me 1400. Divide both sides by 53. And 1,400 divided by 53 gives me a decimal, but remember we're talking about people, so you have to round it to the nearest whole number. So if I round this to the nearest whole number, we had 26.4. 4 is not greater than 5, so I'm going to leave 26 alone. So there would be 26 students, female students, out of 200 who would also be left-handed. All right, next one. If there are 400 male and female students in the 12th grade, predict how many males and females are right-handed in the 12th grade. So now I am looking for this graph up here, and I'm trying to figure out how many males and females were right-handed who got surveyed. So as you guys can see, I'm looking at the right-hand column, and I want males and females. So I need to add these two numbers together to figure out how many males and females would be right-handed. So if I were to take 46 plus 63, that gives me 109 students who were surveyed, said that they were right-handed, who are males and females, and we need to take it out of how many students were surveyed total. So pretty much to figure out how many students were surveyed total, I'm just adding up all these numbers. So 46 plus 63 plus 7 plus 5. So there were 121 students who were surveyed altogether. Okay? So now I'm trying to figure out how many males and females would be right-handed out of 400 students. Okay, so now that I have my proportion, I can now just solve it. So cross multiply 121 times x is 121x. 109 times 400 is 43,600. And then to get x by itself, just divide by that 121 on both sides. And we get another decimal. So again, just round to the nearest whole number. So this would be 360 students. All right, next question. Circle the letter of the sampling method that will better represent the whole population. So it looks like we're talking about the Clinton School cafeteria, and we're looking for student satisfaction. So A here says that Mark surveyed 40 students who are in his classes, and 72% are satisfied with the food in the cafeteria. B says Tammy surveys 65 students by randomly choosing names from a list of all students in the school. 85% are satisfied with the food in the cafeteria. So which one is a better representation of representing the whole population? Well, Mark only surveyed students who were in his classes. So not every student is in Mark's classes. So not every student has an equal opportunity of being selected. However, for Tammy, she randomly chose a list names from a list of all students in the school. So technically, every student had the opportunity of being chosen. So the sampling method that best represents the whole population would be Tammy. And the reason why is because every student has an equal chance of being selected. You're always looking for every student with an equal opportunity of being selected for the survey. Alrighty, last page. 28. Anita wants to know what people's favorite type of movie is. Which sampling method will give valid results? A, she asks people as they are leaving the movie theater. B, she asks all of her family members and friends. C, she creates a poll online on the website called Here's Why Action Movies Are the Best. Or D, she asks every fifth person as they are checking out in the grocery store. So right away, I noticed C, and I know that C is not going to be it because she's only creating a poll online about action movies. So more than likely, people are going to pick action movies as their favorite type of movie that they like if they're on that website. Okay, so definitely not C. I also noticed that she's only asking family members and friends here, so that would not give everybody an equal opportunity to be selected, and more than likely her family and friends are going to have the same taste as what she likes, so not B. The only other one that does not give an equal opportunity for people or makes it a little bit more biased is when people are leaving the movie theater. Think about when people are leaving the movie theater, it's probably because they all just came out of the same movie. So if they're all coming out of the same movie, that means that they all picked that movie to go to, so that means that they're going to like that type of movie. So it's not going to be A. So the only one that makes sense that will give valid results is if she goes to a grocery store, so everyone has the opportunity to go to the grocery store, and then she just randomly chooses every 5th person who checks out. Okay, last question. So a teacher arranged 4 randomly chosen students' test scores in the table below. She said that her class average was an 81.5. How could this be misleading, and what's the best measure of center? So the mean is misleading because the outlier of 45 increases the average score of the students, or the mean is misleading because the outlier of 45 decreases the average score of the students. So as you guys can see over here in the table, student 1 got 100, student 2 got a 45, student 3 got an 89, and student 4 got a 92. So we do have an outlier here of 45, so remember, outliers are going to affect the mean the most. If you have a small outlier, it's going to decrease the mean the most. If you have a big outlier, it's going to increase the mean. So since we have a small outlier, that means that it's going to decrease the mean of the students. So it's going to decrease the average score of the students. Okay? So that answers the first question. The second question is asking what's the best measure of center. So that's talking about these two down here. So the mean would best represent the scores of the students, or the median would best represent the scores of the students. So if I were to find this, so the mean was already set up here, which was an 81.5. So if I were to list these, and 81.5 is going to be about right there, so that doesn't really represent these numbers the best. If you were to find the median, though, it's going to be 90, which would be right there in the center. So the best measure of center that we want, that's going to be closest to the center, is going to be the median, because your mean pulled it down from the center, but your median is still right there in the middle. Okay? So that is it. So this is your review for the data analysis test. So please let us know if you have any questions.